the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise not my petitions, but in thy mercy hear and answer. Amen. In the name of the Father, and of the Son, and of the Holy Spirit.
That was so
Okay. I'm going to have to beg a favor of y'all. Due to absolute brilliance, I left my cell phone at home, which had the picture of the notes that had all the data on the corn and weed problem that we were doing before you left. So I'd like to do is have the physical limits, the logical limits, the objective function. Everybody with it? Now, do remember, X is the amount of tons of corn, and Y is the number of tons of wheat. That's what's making the whole problem fly. The ultimate question is, how much of each do you plant originally in order to maximize your profit? Can somebody refresh my memory on the two physical limits in this particular problem? I think we got that far before the bell rang. There's no bell, but, you know, before the end of the hour. This is the notes from last Tuesday-ish, so almost a week ago. Go ahead and dig them in. Let me have them. It was, or if somebody could tell me the original numbers, we could reconstruct it. There's like a certain number of hours per ton to plant corn, certain number of hours per ton to plant wheat. Somebody find those? Yeah, go. Less than or equal to 120. Okay. Okay.
And then 3x 1y is less than or equal to 250.
This 1y is less than or equal to 150.
Yeah, that's
Okay.
harvesting.
Gentlemen, if you don't have this in your notes, please put them in. We're going to pick up sort of halfway through the problem. This, they said, corn takes 2 hours per ton to plant, wheat takes 3 hours per ton to plant. So the total planting time is 2 times the corn plus 3 times the wheat. And the limit on the planting, it has to be 120 hours or less. So that's the maximum amount you can use. Same thing for harvesting. 3 hours per ton to harvest corn, 1 hour per ton to harvest wheat. So you add them up, 3 times the corn plus 1 times the wheat. And the limit you have is 150 hours total for that. What are the logical limits? Those are almost always the same in every problem. Good. Correct. Why would that be true? Right, you can't plant a negative amount of wheat or corn. So X has got to be greater than or equal to 0, and Y has got to be greater than or equal to 0. In other words, non-negative. Can somebody give me the objective function? First of all, what are you trying to maximize or minimize in this problem? Go. Profit. So what is the profit formula? Profit equals what? Did we get that far or no? Okay. What do we get? Check your notes. We're about to progress beyond that. Yeah.
90x plus 80y.
Yeah, 90x plus 80y. There's no limit on profit. There's no limit on the objective function. These four we're going to be graphing. This one we're not going to be graphing. It's actually impossible to graph this because there's no number here. We couldn't do Chevy-Hen method. So, I think we had gotten kind of close. I think before the end of the hour, I'm just going to do the Chevy-Hen method on these. Oops. You can get it into slope-intercept form, that's fine too. I'm just gonna do the Cheviot method because it's fast. So blank, comma, 0, 0, comma, blank. If you pretend y is 0, did we see x is 60 on the top one? Any questions on that? Does that make sense? So again, if y is 0, just cover it up, and then 2x equals, pretend it's equals for a second. 2x is 120, so x is 60. And now, pretend that x is 0, and you should get y equals 40. So those are your two intercepts for the first. The second one, pretend that y is 0, and x should be 50. And then if you pretend that x is 0, y should be 150. So it looks like the biggest number we're going to need on our graph is 150. So just to make it nice and square, I'm going to bring it out to 150 and 150 both directions. Let me refresh my memory of why my graph is so lopsided. Abby, with me. Why is this just big, stumpy?
Well, because you don't have to go in the negatives.
Right. We never go negative. It's impossible. So we get to skip that. So I'm going to kind of guesstimate these. 60 is like 2/5 of the way over. Please do mark anything if it's not. Question. Katie, talk me through these. What kind of dots for the top equation? For any solid. So is it 60 comma 0, and then 0 comma 40. 40 is kind of like 32. Solid or dotted line? Solid. Which way do you shade? How do you tell? Test a point. What's an easy point to test if you can do it? 0. Try 0, 0 in here and tell me what happens. It would, so it's true, so you shade where? Yeah, you shade down towards 0, 0. You okay with that? That's actually the main part of the problem. Once you get these inequalities, you can graph them. So we're going to shade it eventually. I'm just going to wait till the end, so not to make a mess. This one, 50 comma 0, so it's a little bit closer in. And then the other is 150, which is way up here. And it should look like this. Solid line is the same thing if less than or equal to. If this had been just plain old less than, it would have been a dotted line. But it's not. There are two more things to shade, two more things to graph, I should say. Blaze, what would those be? There are two things I have not graphed yet. Yeah, oh, and by the way, the shade, this one also shades down, is 0, 0 comes up. Yeah, how do you shade x is greater than or equal to 0? Like, where do you shade? Yeah, to the right of 0. And how do you do y is greater than or equal to 0? Shade up. Does everybody see the region that is covered every single time? It's a funny sort of, yeah. Yeah, it's kind of like a triangle with a snippet, but bit out of it. Yeah, it's a quadrilateral. It's sort of like a lopsided diamond. That's the solution region. All the points in the solution region are physically possible for you to plant. Like, for example, if somebody asked, is it possible to plant 10 tons of corn, 10 tons of wheat? Look at 10 comma 10. What would you say? Possible or no? Yeah, because it's covered. What about 150, 150? Heck no, it's way in this non-shaded region. 60, 60 would still be bad. Does that make sense? So this tells us we're kind of limited. What do we do with that shaded region? First of all, Mary, how many points, this is kind of a trick question. How many points are in that shaded region? Infinitely many. There are infinitely many points we could try that work. One ball go away. And of course, I'm being recorded. For those of you listening at home, hi. Just a second, I'm gonna get a slurp of water. Yeah, it's a lot better. What theoretically you do, you plug in all the possibilities into the objective function and see which one gives you the most money. I should put dollar signs. But plugging in an infinite number of points is kind of prohibitive. There is a rule, and I'd like you all to write this down. Rule. Extreme values come from extreme points. This will save us a lot of work. Write that down. Extreme values come from extreme points. What does that mean? If you're looking for a maximum or a minimum, those are extreme points, like something that's the absolute highest or the absolute lowest. Look at the shaded region. There are only a certain number of extreme points. Extreme points are the things on the outer edge, as far from the center as you can get. As a matter of fact, there are only 4. A point here, a point here, a point here, and a kind of a mystery point here that we don't know where it is. Does that make sense? Now, we could try any of the points in here, but it takes forever. We could try any of the points along the perpendicular, along the perimeter, but there's also an infinite number of points there. But the rule says extreme values come from extreme points, and actually there is there's kind of a Latin word for extreme value or extreme point. It's a vertex. Actually, I think that comes from Greek. A vertex, by definition, is an extreme point. It's something that is as far out as you can get. Like a triangle has 3 vertices, 3 points. It basically are the corners. Your job is to find the corners. 3 of them should be relatively easy. 1 of them takes a little extra work. Let's see if we can get it. Vertices, which is plural for vertex. Can somebody name one? Go.
40.
And it needs 2 numbers though. Something comma something. I agree, by the way.
So 0.4.
Yes, this point here is 0, 40. 0 spaces left, right, 40 spaces up, down. So list this as 0, 40. That's a vertex. Courtney, give me another one.
0,
0, definitely. Give me another one. 8. We've got 0, 40, 0, 0. What's another vertex? 50, 0. Correct. Why is 60, 0 not a vertex? I mean, it's a point on the graph. Why isn't it good? Right, it's not on the solution region. It's too far out. It's on the non-shaded part. So we've got 50, 0. There is one more, but we don't know where it is. This thing. I'm going to call it quote unquote a mystery point. Mystery vertex. We need to find where this is because that's one of the 4 things we need to plug into profit. And for all we know, that might be the best one. How do you find the mystery point? Well, back in heaven knows how long ago, and a little bit of a touch this week, not this week, last week, whenever I studied last, it's forever ago. How do you find where 2 lines cross? Let's just say this line is 2x plus 3y equals 13. And then this is 3x minus 2y equals, 13. How do you find out where those 2 lines cross? You've done this before many times, last year and the year before. Go. And What's that? I have somebody there, go ahead, go ahead.
It's like to solve.
Solve it, how? There's several possible methods. Name a few. Elimination is one. That's where you get somebody to cancel. What's another one? How do you find out where two lines cross? You can do elimination where you get the x's or y's to cancel. There's another, yeah. Graphing, that's another one. Give me another one. Kramer's rule. Curious how many people remember that. We might go over it later, yeah. Augmented matrices, wow, that's an obscure one. Very good. Substitution, right. There are lots of different ways to do it. Pick your favorite. But the thing is, by the way, these are just sample ones. What two lines are crossing here? Can somebody give me the equations of the two lines? Don't worry about the shading, just the two lines. Pretend it goes forever. Can anybody give me the equation of those two lines? Give me one of them. Go, let's. Yep. 2x plus 3y, and I'm going to do something strange here, equals 120. Now, I do not have amnesia. I do remember it's less than or equal to. But all I care about is the line. For like 30 seconds, all I care about is the line, because all I care about is where the lines cross. The shading is irrelevant for this 30 seconds. Somebody give me the other one. Abby. What's the other one? We've got the 2x plus 3y equals 120. What's the other one?
3x plus 1y is equal to 150.
Yeah, it's equal to 150. Let me see why I'm doing equals. It's temporary. It's like for 30 to 60 seconds. Just long enough to solve. Tell me how to do that. Somebody talk me through substitution, elimination, favorite method. Take your pick. I'll try.
Sure.
Go.
That's a substitution.
Okay.
No.
That's not a bad idea in this case.
Okay, well, let's just do that.
Substitution is nice if you can get a letter by itself easily. Can you?
You multiply the bottom by the whole, right?
Oh, that's actually elimination. You want to do that instead?
See, that's where I'm.
Okay. Substitution, you could have gotten y by itself, subtract 3x on both sides, and then plug it in. I'll do elimination, what the heck.
Okay.
It's actually a little faster. So multiply the bottom by what?
3.
By 3. There's one little catch. I like the 3. What would that give you, by the way?
9x plus 3y equals.
Okay. 9x plus 3y equals 450. Good. There's one little catch. I want to get the, you're looking at the y's, right?
Yeah.
I want to get the y's to cancel.
Oh.
They're not going to cancel yet. There's one teeny thing.
The negative 3.
-3. Make this, what would it be then?
Negative
9y?
plus negative 3.
-3x is -450. I would scratch this one out now. Remember this elimination trick? If you magnify the other line by a big enough number, you might be able to get one of the x's, either the x or the y's to cancel. Let's see what happens. Let's add them.
Negative 7x.
Good, -7x.
Equals.
Good, because these cancel, equals, we got 120 and -450.
Negative 330.
-330. Brace yourself, these are not going to be whole numbers. It's okay. It won't kill you. Keep going. Do one more step, get x by itself.
Divide each side of the same.
By
Negative.
-7, yes. What do you get? Does that go in evenly?
No.
No, it does not. What do you do with it?
Oh.
The negatives cancel, which is nice. What do you do with numbers that don't come out evenly? In my class, anyway.
Leave it.
Leave it. Leave it as 330 over 7. The decimal on this would be disgusting. It would be a 6-digit repeating decimal. So I would not advise that. If you tried to get the 6-digit repeating decimal, God help you when you plug that in. I just, can you, I don't even know. I'm too scared to even look at it. We're almost done with this problem. We've got x. Mary Claire, take over. How do you find y? Yeah, unfortunately you plug it in. Take your pick, top or bottom? Either one you will. Top, okay. Let's try it. 2 times this disaster, I love the thing, plus 3y equals 120. Let me recommend something to you. If you don't like fractions, who doesn't like fractions? But if you don't like fractions, there is a way to kill them. Do you see this bar here? What does it mean mathematically? Go. Division. They're dividing by what? 7. How do you cancel that, Josh? Multiply by 7, as long as you do it to both sides. Here's what you do. Times 7, times 7, times 7. Leave this 2 here. 7's cancel, multiply, multiply. So can somebody do this for me? Mental math. What's 2 times 330? Yeah, go. 660. Plus what? Keep going. The thing you shorten your way, sorry. 21y equals, I mean, no, 7 times 120. Yeah.
840.
840. If you do a mental math, 7 times 100, 7 times 20. Where do we get it? Somebody solve that for me. Mary, take over. Good. Subtract 660. Say cancel. 21y equals, what do you so far? You have to borrow a little bit. Since it's 7, 1. I'll do the 0. You're welcome. What's 14 minus 6? 8, and then 7 and 6. There you go. One more step. Yeah. So y equals, now if you leave it as 180 over 21, I would take off a point. I mean, why? I'd probably take 1 out of 10. Any idea why? Good. It's not simplified. What number goes into both of these at the same time? Yes. 3 definitely does. How many 3s are in the top? 60. How many 3s are in the bottom? 7. Why is 60 over 7? Your mystery point is 330 over 7, comma, 60 over 7. That happens in real life. When you're running problems like this in real life, you're not guaranteed to get a nice round number answer for x and y. There's one more step to this problem before we're done. What do you do with the vertices? What's the purpose? Sam. Why do we find these things? We just all these blood, sweat, and tears to find this mystery point. Why? Why do we need these 4 points? What do we do with them? What was the original problem asking?
To find the maximum profit.
Maximum profit. The profit is calculated by using this formula. If only we had x's and y's, we could find profits. If only we had x's and y's. Que lastima. I don't even know how to say if we only had a vertex in Spanish, but whatever. What do you do with these? Nick.
How do you just
Plug them in. Do it.
Well, it's gonna be the last one.
Maybe. Maybe.
More than
Maybe. Go ahead. Plug in the first one just for reference.
90 times 0
Yeah, 90 times 0
plus 80 times 4.
plus 80 times 40. What would that give you?
300.
2 zeros.
3,000.
Yeah, so $3,200 profit. If you plant no corn and 40 tons of wheat, remember these are X and Y, those are corn and wheat. If you plant all wheat, 40 tons of wheat, no corn, you'll get this much profit. Take over, kidding. Well, I take 2 of them, this next one's kind of dumb. What if we get 0, 0? Yeah. That means you stay home and don't plant anything, which is pretty realistic. You will get no profit. I hope that didn't shock anybody. So, go ahead. Next one. 90 times 50 Plus 80 times 0. What does that give you? 4,500. That's the best one so far. Now, here's a point where I do not blame you for grabbing a calculator. You don't have to. I'll show you a trick for if you don't want to use a calculator or if you don't have one. By the way, I have plenty if you need to borrow one. Plugging this in is a little bit of an aggravation. If you have a graphing calculator, by the way, it's actually quite nice because you can just type it and hit enter. If you have what's called a display calculator where it has two lines, one for typing and one for entry, it's not too bad. If you have one of the old-fashioned ones where you have one line, which I grew up with, it's super duper annoying. Now, question is, can we get above 4,500 using this? Now, the way you could without a calculator is divide these out and get a mixed number. So this is 7 goes in 4 is 28, so that's 4, that's 5. 7 goes in and that's 47 and 1/7. And this is 7 goes in, so it's 8 times 7 is 56, and 4/7. So 47 and 1/7, and 8 and 4/7. What I would do if I needed to get a really quick estimate, plug in 47 and plug in 8.5, which are a little better to deal with than these things. There's nothing wrong with plugging in the actual numbers. I'm going to do it just to prove to you that you can survive the process. I'm going to do 90 times 330/7 plus 80 times 60/7. And I'm going to use what I call the machine gun trick. You notice they're dividing by 7? Multiply everything by 7. Cancel, cancel, cancel. Well, actually it's 7/7. So we're getting a common denominator. Forget I did that. I don't have an equal sign. That was stupid. Hang on a second. Over 1. This is going to hurt after all. So we've got, oh merciful heavens. 0, 0, 0, 0, 7, 9. Oh, that was easy. 29700. This is much more efficient on a calculator, even I will admit. 60 times 80 is 4,800. So add these up. 34,500 over 7, and now divide that out. 7 goes into 34. 4 times, that's 28 with a 6. 7 goes into 65. 9 times 7 is 63 with a 2 left over. 7 goes into 20 2 times with a 6 left over. 7 goes into 60, 56 with a 4. So your last one is $4,928 and 4/7 dollars, which is awfully weird. I would not do this if walking into a bank, but if you divided 4/7 out, you could get the number of cents. All I wanted to know is which value of corn and wheat maximizes your profit. Somebody give me the final answer in words. In other words, if you just circle this point, I'll probably take off 3 out of 10. Because if they give you the problem in words, I want the answer in words. Can somebody put it in words for me? Sam, what's the final? It said, how much corn and wheat should we plant? And I would recommend you don't use decimals. In other words, there are only 4 possibilities.
So it's like 47.
Yeah, I like 330 over 7. You can do 47 1/7, that's fine. So 330 over 7 what?
Tons of corn.
Excellent. Tons of corn. And then what?
Just plus. Oh wait. Sorry.
Just how much of each do you plant? And then
60 over 7.
6 over 7. Tons of wheat. And that, my mathematical friends, is the end of the problem. Now, the first time you go through it, it takes forever, just because we're explaining things. Really, really quick summary. First, define your variables. Find out how many there are. Like, how many unknowns are in this problem? Ultimately, there are two. How much corn, how much wheat? How do you find that? Go to the very end of the story problem and look at the very last question they ask. I think in this case, how much of each should you plant in order to maximize profit? Now, how much of each should you plant? There are only two things to plant, corn and wheat. So you know there are two variables. So step one is get your variables and tell the world what they are. X is the number of tons of corn, Y is the number of tons of wheat. Step two is get the physical limits, logical limits, and objective function. Physical limits is what you're physically doing and any limitations on it. In this case, we're planting and we're harvesting. And there are limitations on it. Here's the amount of time it takes to plant corn, to plant wheat, and the total planting time maximum. This is harvesting. Here's how long it takes to harvest corn, harvest wheat, total harvesting time. So make sure less than or equal to is for a maximum. Logical limits are anything that, or you're forbidding anything that doesn't make sense. Negative values don't make sense when you're planting corn and wheat. X greater or equal to 0, Y is greater than 0. The objective function is whatever you're trying to maximize or minimize. In this case, profit. So for profit equals 90x, $90 per ton of corn, $80 per ton of wheat. Does that kind of make sense? I'm going super duper fast. Step 3, graph all the graphable things. Note this is not graphable because we don't have a number here. So graph, graph, shade, 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 boom. You've got this weird little shape. That's your solution region. Step 4, find the vertices. 3 of them should be easy to find, 1 of them you need to work, usually with substitution and elimination or something, whatever's your favorite. We found out it was some icky number, 330 over 7, 60 over 7. Step 5, plug in all your vertices and see which one maximizes or minimizes your objective function. That finishes the problem. Does that make sense so far? All right. The worksheet, go ahead and take that out. Problem number 1 is virtually identical to this, just different numbers. Did I do wheat and rye? Or did I do corn and wheat? Corn and wheat, okay. So sometimes people get freaked out, but it's the same problem, just different crops. Problem number 1 should be relatively easy to do. Turn over to page 2, problem number 2. You're an office manager and you're trying to maximize storage space. Just for practice, let's see who can find the variables. How many variables are there? Read for about 30 seconds and see how many variables there are. Can we see it? Blaze, how many variables? 2. What are they? How many cabinet A's? How many cabinet B's? You might be tempted to put A equals cabinet A's and B equals cabinet B's. There's no law against that. It's just that you'd have an interesting graph with an A axis and a B axis. So if that doesn't freak you out, it's okay. I did X equals the number of cabinet A's and Y equals the number of cabinet B's just because graphing X and Y axes just makes my heart feel better. You don't have to. Can somebody tell me the not the equations or formulas, but what are the physical things you're doing? What are the physical limits in this problem? What exactly are you trying to do? You physically are going, maybe with a bunch of people who can help carry stuff, are trying to do what? Okay. Maximize your storage space. What factors are considered here? What do you have to consider when you're making your purchases? Go. Budget. How much money you spend. That's 1. That is one of your physical limits. Budget is one of your physical limits. Go.
How much floor space you have and how much floor space you have.
Right. How much floor space you're taking up. Do you want to maximize or minimize the floor space taking up? Minimize, because you want the human beings to have somewhere to walk. I mean, we could fill 95% of this room with, filing cabinets. We just wouldn't be able to get in here. Or if you got in here, you wouldn't be able to open the drawers because they'd bang against each other. So you want to minimize the amount of floor space you take up. You want to maximum, so you got to stay within, you can go up to a certain amount. The office supervisor will say, I'll let you take up to 18 square feet of floor space, but no more, because Phil needs a place to put his desk. You get the idea? In the paper, how much floor space are you limited to? Does it say? Yeah. 60 square feet. Could you go less than that? Yes. Could you go above that? No. Is that a maximum or a minimum? Maximum. So what symbol would you use? Greater than or equal to or less than? If that's the absolute maximum you can go. Like my maximum weight is like 160. Okay. Which is what that. That's another story. Less than or equal to, correct. That's for a maximum. What if you had a minimum? Like if you have to do at least this much or more. Problem number 3 actually does this. What symbol would you use? Blaze. If you had a maximum, what inequality symbol would you use?
Yeah, so
Say again? Less than or equal to. How about a minimum? Greater than or equal to. Good. So you've got, by the way, a budget. Was it $600? Is that a maximum or a minimum? Like if you're you would say, here's your budget, here's how much you can spend to get cabinets. Is that a maximum or minimum? That's a maximum, yes. By the way, if you ever get hired somewhere, please know the difference. Well, I thought I had to spend a minimum of $600. I'm like, you're fired. You are so fired. Well, I only spent $15,000. You are so fired. So that's the difference between those two. The second physical limit is budget. Is there anything else you have to keep track of? Is there anything else they mentioned? They got floor space and they got budget. What else? There's one other thing that at least that they mentioned. Sam, what else do they talk about? What else do they give you numbers for?
Cost for each type of cabinet.
Cost, and that'd be budget. What else? What other numbers did they throw at you? Because in a story problem, when they throw numbers at you, those are usually important. Like the words could be blah, 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 blah. Courtney? Yeah, storage. Storage space. Do you want to maximize or minimize that? In other words, is your job to get a lot of storage space or a little? Go ahead and look at that. It should say, like, the last statement or the last question of the story problem. In order to what? To maximize your storage space. So you want to have as much storage space as possible, but you're going to be limited by your budget and such. The thing you're trying to maximize or minimize is called the what? Josh? What's the special nickname for the thing you're trying to maximize or minimize? The objective function. That's going to be storage equals something X plus something Y. Make sense? You can use whatever variables you want. Everybody got the idea? You should have enough ammo, so to speak, to graph those. Make sure you include logical limits on X and Y. There are logical limits. You'll have to figure those out on your own. And you should have enough to finish that. Flip to problem number 3. This will just take 2 minutes. I just want to warn you on a few things. I want you to fill in one thing. Thank you to the people who were here the other day and reminded me of this. I copied this word for word out of a book and then used the reference at the bottom. So it's legal. But the book question wasn't being very specific. I'd like you to add one thing. We're trying to minimize cost. That's the objective function. They did not do a very good job of explaining that. I think they just say, what's the best mix? And I said, best for what? Best for making rabbits fat or what? So it's for minimizing cost, minimizing cost. Write that down somewhere, because the problem itself doesn't make that very clear. You have quite a few things to keep track of. You are raising rabbits. You are mixing your own rabbit food. You have this basic rabbit food type stuff that you can mix together. There's like formula A, formula B, or something like that, or X and Y. I forget which. What things do you have to keep track of while you're feeding your rabbits? Mary Clark, name a few things that you have to keep track of when you're feeding. Anything they give you amounts for. Yeah, grams of fat. Give me another one. Grams of carbohydrates and protein. Question, did they give you anything in there that indicated whether those are maximums or minimums? Good. Those are minimums. You have to have at least that much, otherwise your rabbit's going to either starve or get too skinny or not have enough muscle mass or whatever. Minimums. Those are physical limits. What would you use if it's a minimum? You have to have a minimum of blah, 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 blah protein. Go. Good. Yes, greater than or equal to. The physical limits would have greater than or equal to. Just so you know, when you graph this thing, you're going to have a bunch of lines and such. When you do a greater than or equal to, the shading looks different. It shades out. You're going to have a shading that looks like this. And the vertices are going to look a little different too. There's a vertex here where they cross, a vertex here where they cross, and a vertex here. It looks quite different when you're shading outward. You can still find the vertices, but you may have to keep track of which lines are crossing. So I think in this one you may have to find two different crossings and not just one. So I just labeled them like P for the protein line, C for the carbohydrate line, F for the fat line, which sounds kind of awkward. And then find out which one's crossing which. Find the intersection points. Those will be your vertices. There will be one on the x-axis, one on the y-axis, and probably two in between. Your job is to find those and to ultimately plug them in to your cost function. Does that make sense? Are there any logical limits to protein and carbs and fat? Or actually, I should say, what do X and Y stand for? I think it says. Go. Yeah, X is how much of the first food type, and Y is how much of the second food type. I think in ounces or grams, or I don't know if it's metric system or not. Are there any logical limits to the amounts you can use? By logical limit, I mean something that's eliminating what's absolutely impossible. Yeah. Yeah, you can't have a negative amount of rabbit food. So you've got to be greater than or equal to 0 for logical limits. Does that make sense? All right, what I'm planning to do is I'll give you the rest of the hour to work on this. For the people who were here, you might have it done already. Congratulations, you have a very light load the next 2 days. And then tomorrow, I'm going to give you probably the first half of the period to work on it, and then I'll check it off near the end of the hour. Does that make sense? Yeah.
I just had a question about this problem. It says that rabbits should be fed no more than 5 ounces of food per day.
That
That is a physical.
That is a physical limit. That's a kind of a hidden one. As a matter of fact, let's just do that one together. The total amount of food should not exceed what?
5 ounces.
5 ounces. Oh, it is in ounces. That's weird. Oh well. As long as the food's in ounces and the other stuff is in grams, it's fine. Can somebody tell me how much total food there is? Give me a formula for it. It's easier than you think. Go.
It's like X plus Y is less than.
X plus Y. X is how much first food, Y is how much second food. X plus Y has to be what, I'm sorry?
Less than or equal to 5.
Less than or equal to 5, because you can't go above that amount of food. So there will be, by the way, one more line, and if it's less than or equal to, it's shading down. So you're going to get this sort of half moon shaped thing. when you're all done with your shade, with a couple of vertices in between. Everybody good? Hopefully. I'm gonna post this on YouTube also, so if you ever wanna hear some of this again, including my stumbles and bumbles, feel free to click like and subscribe. And last 5 minutes are all yours. Go to it. People listening at home, I hope I emailed it to you. Well, I'll check, and if I didn't, I'll email it to you in the next 5 minutes, which you won't know about until tonight. Wait till you, never mind. See y'all later.